Okay, we're going to talk about a lot of things in this class. So we're going to talk about variables, functions, data types, and operators. But these are basically familiar to you, except for maybe data types, just from basic math. So you're familiar with the variables in basic math. We talk about the variables, and we talk about like x, y, z. We use that often in math. Functions, I think you're also familiar with from mathematics. Data types we haven't done. And operators mean mostly plus, minus, times, divided by, and then there are a few other ones. So that's what we're going to do now. Okay, so I'm using Visual Basic 2008 Express version, so it's free. So I'm referring to the text here. They said, as you learned in Chapter 2, a line of code in a Visual Basic program is called a program statement. Okay, we didn't stress that, but any line of code is a program statement. And a program statement is any combination of Visual Basic keywords, properties, object names, variables, numbers, special symbols, and other values. Okay, a complete program statement can be just a simple keyword such as the word "and." So just that would be considered a program statement. And this halts the execution of Visual Basic program, or it can be a combination of elements such as this. So we did this last time, right? So that's also called a program statement. So they say in the following chapters we'll learn the most important Visual Basic keywords. So like and, or if, and then. Those are called keywords. And also program statements, as well as many of the objects and properties and methods. Remember, we talked a little bit about methods. Method is basically a function provided by Visual Studio Controls and the .NET Framework. You'll find that these keywords and objects complement nicely the programming skills you've already learned. So the first topic we're going to talk about are variables, and then data types. And usually when we make a variable, we don't usually use x or y when we're doing programming, because usually programs are longer, and you're going to forget what x and y and so forth are supposed to stand for. And so we want to give the variable some kind of name that reminds us of what it's being used for. So here we have a variable called last name, okay, and we assign it some text. Okay, and the reason I know it's text is because it has the quotation marks on either side of it. So we're assigning the text Jefferson to this variable called last name. And here we're assigning to the same variable, last name, a different piece of text. Texts are also called strings. So a different string, it's this address. And this is something maybe we're not quite used to. That is, both of these are something we're not quite used to, because usually when we have variables we assign them numbers, but in programming we often we will certainly assign numbers to variables, but we also want to be able to assign things like text to variables. Now, once you've made this assignment, and recall that we call this an assignment operator, not an equals operator. There's no equals operator. Anyway, it's called an assignment operator. Once you've made this assignment, now last name can stand as a replacement for this, for the text here. Okay, so if you wanted to, you could take a piece of code like this, which is what? Take label 1, its text property, and instead of assigning it this, you can assign it this, because this is equal to that, or has the value of that. Okay? So you can do this kind of thing. And now label 1.text displays, oh, I guess they're talking about still Jefferson. So if it was assigned Jefferson, then label 1.text would show Jefferson as its text property on your form. Now, a little bit different than in mathematics, we have to do this kind of thing first. Now, sometimes in math, I remember when I was in elementary school or whatever it was, and we were learning about variables, they would always tell us to say what the variable stood for. So they would say something like, let x be the number of apples that we have. So we're kind of declaring what x is before we actually start using it. And in programming, you're supposed to do that. So I'm supposed to say that last name is I'm supposed to tell it say what kind of variable it is. So is it going to represent strings, or is it going to represent numbers, or maybe dates? These are different situations, and it's best if we say it in advance. So we're supposed to, and the way that we say it is by writing something like this. This will say that last name is going to be a string variable. And what that does is that allows the computer to reserve a certain amount of space for this variable, and that makes the program more efficient and faster. So the way that you do it is you write dim, and then the name of the variable, and then the type that it's going to be. So, or you say as, and then the type. So as string in this case, because it's representing a string, or as I called it, also text. And this is called declaring the variable. And generally speaking, you're supposed to declare the variable. And dim, they say, stands for the word dimension. And if you think about it here, we say we have a variable x and we have a variable y. We also say this is a two-dimensional graph, and the first dimension is x, and the second dimension is y. So it's that use of the word dimension. So it's like we have a dimension here and a dimension here, or a variable here and a variable here, but they use the word dimension to declare it. So dim stands for dimension, and again, the way that you declare a variable is you use the word dim, and then you give the name of the variable that you want to create, and you have to say what type of variable it is, and you say as and the type. And we'll learn about the different types that you can declare a variable as. This one is being declared as a string. And this is called setting aside space for the variables. We're using the so-called dim statement. They say that this declaration reserves room in memory for the variable when the program runs, and lets Visual Basic know what type of data it should expect to see later. Although this declaration can be done in any place in the program, as long as the declaration happens before the variable is used, most programmers declare variables in one place at the top of their event procedures or code module. So basically at the top of the code. And what is a string variable? That is a string. A string contains textual information, for example, like words, letters, symbols. Even numbers can be part of text or part of a string, but as I explained earlier, if you put quotes around a number, then it's going to be treated as text, and you can't manipulate it as a number anymore. In other words, you can't add 2, like 8 plus 8, when they're both textual items. So it loses its kind of numeric qualities. And the practice of declaring variables is useful because of the idea of memory management. Now, usually we don't think that we have to worry too much about memory when we're writing our little simple programs, but in big programs it becomes an important issue. So it's important to declare the variables, especially for big programs, but we're going to insist that we do it all the time. Now, they do mention something called implicit variable declaration. Implicit means it's implied. In other words, you don't actually declare it, it's just implied by what you're doing. So they say if you really want to declare variables the old way, the old way means before the .NET framework came along, that is without explicitly declaring them using the dim statement, you can place the option explicit off statement at the very top of your form or module, and then you don't have to do that. You don't have to declare, but we don't want to do that in general. Now there's another option as well, which is you can use the option infer statement, and if you write that at the top of the code, this allows you to declare variables without specifically identifying the type used. So here we're doing dim attendance equals 100, and we didn't say in advance that attendance is a numeric variable or an integer, but it's implied because this is equal to 100. So they say that this will declare the variable named attendance as an integer because 100 is an integer expression. In other words, the option infer set to on is the same thing as typing this. So this is an explicit declaration. So we should follow this practice. Now notice here that they're declaring attendance as an integer. That we've talked about already. But then they're actually assigning a value to it at the same time, and you're allowed to do that. They say if you wanted to do this, you would write this at the top of your code. Okay, let's try this. So I want you to try and make a form like this. So go ahead and make this form so you can see what it has. 2 labels, 2 buttons, and you can stop the video while you make it. And let's just run it and see what it does just for a minute. So I click here. Oh, sorry, I forgot to put anything in there. So let's start by putting something in there. So make the form, and then let's put something inside each of the buttons. Okay, so you want to type this, but before you type it, let me just show you one thing. So I did dim last name as string, so I'm declaring a variable called last name as string. Then I'm doing dim first name as string. I actually mean to put an E there, but even if I don't, as string. And then I continue further. Now look at this. The first name has this kind of, I don't know if you can see the color, but it's a green underline on it. And that's because it's just telling me that this variable has not, in the code, been assigned a value yet. So last name is later on assigned a value. You can see it's assigned the text abe. Okay, but first name never receives a value. So it's telling me that. Okay, there's nothing really wrong with it. You don't even have to use a variable. You can declare it and never use it. But that's what's happening there. Now the rest of this, before you type it, as I said, last name gets the text abe, and then we take last name and we assign it to label 1's text property. And then we can reassign last name later to a different value. Instead of abe, I assign it this, and I can take now label 2 and assign its text property the new value of last name. So last name has the string abe, has the value abe, and then that gets put in here, and then we reassign last name. The code doesn't go back up to here and change it. Let's see what happens. So when I click on show, abe goes in here, and the other name goes in here. So as I said, the code doesn't go back and feed in the new assignment of last name. Doesn't go back into here and then into here. Okay, so it kind of goes in order. So last name gets a new value here in this statement, but then that's only fed into here at this point and never used again in this code. So type in this code and check to see if it works. Notice that I didn't use actually first name, but I did declare it. And if maybe if you're writing a program and you see this afterwards at the end, this might be a sign to you that maybe you mistyped the name of it. because it was never used. So you might check to see if it's actually spelled correctly or not. Now here's a box that explains how you should name your variables, or what kinds of, we call them variable naming conventions or rules, that are usually observed when you give a variable a name. So you don't want your variable names to be really long if you can avoid it, but you don't want them to be too short so that you don't know what they mean or what they stand for. It says that you should begin each variable name with a letter or an underscore, so not a number. This is a Visual Basic requirement. Variable names can contain only letters, underscores, and numbers. Now remember, in another video you saw last week, we talked about the Hungarian naming convention, and that's a good practice to follow. We won't be following that in this text, but it's definitely a good practice to follow. Although variable names can be virtually any length, try to keep them under 33 characters to make them easier to read. Make your variable names descriptive by combining one or more words. So we said sales tax rate, or for example, instead of just tax or just rate. Okay, so it's better to make it somewhat descriptive. And you can use a combination of uppercase and lowercase characters and numbers. An accepted convention is to capitalize the first letter of each word in a variable. For example, date of birth. You see D, capital O, and capital B. However, some programmers prefer to use the so-called camel casing, making the first letter of a variable name lowercase to distinguish the variable names from functions and module names. So this is actually usually the way I name variables. So like here. So O is capital and B is capital, but the first word's letter is not capitalized. Or here's another example. Employee name. So N is capitalized, but not E. They say that usually functions and module names begin with uppercase letters. So if you follow this kind of convention, you know this is a variable, and if it's a function, it'll start with a capital letter. So these are conventions. They're not hard and fast rules, but they're things that we try to use, or rules that we try to observe. Now, two more conventions are, don't use Visual Basic keywords, objects. So for example, you should never use AND as a variable name, END. That's a Visual Basic keyword, or if. And objects or properties as variable names. If you do, you'll get an error when you try to run your program. Now this is basically like the Hungarian option, Hungarian rule rather. And here they call it the Hungarian naming convention. It's a little different than we saw in the other text, but it's the same idea. For example, this one. Okay, so in the other one they put a space or an underscore between these, but here we're just saying string name. str means it's a string, and then the name of the variable name. Or you might say string last name. str last name. And this is a very good convention to follow.